Alrighty, here we go. Before we jump into your actual lesson, I want to show you what your homework looks like. Your homework is very, very short, not many problems. The basically your homework you will do on a separate piece of paper. There's 7 problems here. You'll take a picture of your homework and you'll submit your answers on here. This will show me what percent or how many points I'm going to give you on your homework. The issue here is normally on Math Excel, you're able to get it wrong. It says it's wrong. You try again, you do it again, you keep going until you get it right. This is a one and done thing, but I made sure that the problems were basically pretty easy. Math XLs were much more challenging and not great. So you guys have these 7 problems. You need to read how it says to enter your answer. For example, it says give the volume, but just give it as a single number without units. So if the answer was 60 meters cubed, you would just put 60 here. Then same deal here. All you're doing is putting your answer. On this one right here, it says give your answer in respect to pi and how you'll put your answer. For example, 20 and then pi for pi. So you would say 20 pi, no units. For the radical one on here, let's say it was 20 rad 3 for the volume. You would use no spaces, no uppercase. You would put your answer in just like this, but with the correct numbers. 20 rad 3. You put your answer in and you press enter or submit it. You do have some figures that you might need to be reminded of what the formula is. So you have a trapezoidal prism. You might need to remember what the formula is for a trapezoid. And then actually I wrote it right there, which is nice. So just make sure you're reading how I ask for the answers. If it says no units and you write 12 IN for inches, it's going to mark it as wrong. I will do the same thing that I always do. I'm going to go over and give you guys 1 point if you are between 0 and 34%. 34 to 67% will be 2 points. 67 to 100% will be full credit. On this problem right here, make sure you understand I gave you everything. Do not try to do trig. If you do trig and you do it correctly, you'll end up with 4.1 when you round, but why would you do that when I give you everything? So you will be running with these numbers right here for the volume. Does anybody have any questions? Don't have a set of scissors. Any other questions that relate to what we're doing? No? Great. Okay, so let's go ahead and jump into today's lesson. As you know, we only have 30 something minutes. So we are jumping into volume, and then we're going to be looking at pointy figures, and we're going to be looking at spheres. We do 3 lessons this week. We do a lesson on buoyancy and on density next week. You know, next week is a 4-day week. This is a 3-day weekend. We're going to get through this chapter, do next chapter, and then we are done. So today's lesson is going to be on volume of prisms. We are not going to do pointy like pyramids, and we're not going to be doing spheres. We have already talked about 2-dimensional figures. If you go all the way around a 2-dimensional figure, what do we call that? Perimeter. That would be your perimeter. If we talk about the space inside of a 2-dimensional figure, what is that called? Area. So volume is just going to be the space in a 3D figure. It's basically asking how many of these 1 by 1 by 1 cubes, a 1 by 1 by 1 cubes can fit inside of your figure. So if you were talking about a soup can, let's say, for a soup can, the label would be the lateral area, the metal would be the surface area, and the amount of soup inside would be your volume. Does anybody have any questions? When you were introduced to volume in like 5th grade, they probably just gave you a bunch of little sugar cubes and you saw how many could fit inside the figure. With a rectangular prism, that's easy because a lot of times it'll fit a perfect number of cubes inside. But if you're talking about any other figure, it's going to be parts of cubes, and without the formula, it's a disaster. As always, I told you for this chapter, do not memorize formulas. Understand formulas. So here is the thing that you need to understand, and we've talked about this before. If you have any 3-dimensional figure where it is just the base on top of itself over and over and over, that is just going to be volume equals area of base times height, big H for height. That's it. So volume of any prism, whether it's right or oblique, will be volume equals area of base times height. Oblique means it is like the Leaning Tower of Pisa. It is not standing straight up and down. Okay? So even an oblique, if you look at an oblique, let's say we looked at an oblique cylinder, is that just the circle stacked on top of itself over and over and over? That was, yes. It looks a little funny because they're shifted to the side slightly. But since that is the base on top of itself over and over and over, that is still going to be area of base times height. Does anybody have any questions on that? Now, think about a pyramid. Is the pyramid the same exact base stacked on top of itself over and over and over? No. What is really, really cool, if anybody ends up taking calculus, what they will do is they will say volume equals base times height. And what they will do is this formula will work, but in calculus, what they do is they account for the fact that the square is getting smaller and smaller and smaller. They will put a formula in for the base, which will adjust what happens to this square. And it will adjust from going from the full big square all the way to 0 for the smallest square, which doesn't exist. So that's what calculus will do. And it could do that, like if you had a sphere could be thought of as a bunch of cylinders on top of themselves, a bunch of disks. And what calculus will do will account for the fact that the disk is getting bigger and then they get smaller, which is really cool. But for our uses, we will just be looking at if the figure has a base stacked on top of itself a bunch of times, it is area of base times height. Anybody have any questions? Now I want to remind you of all the possible bases that we could have. We could have a triangle. In a triangle, and I would recommend putting this down, a triangle would be 1/2 base times height for a triangle. We could have a rectangle, or you could have a parallelogram, and that is going to just be base times height. Notice I'm using the baby b and baby h because that is the base of the base, not the area of the base. The little h means the height of the base, not the height of the whole figure. Another one we could have is 1/2 apothem times perimeter. That would be for a regular polygon. Another one you could have is 1/2 diagonal 1, diagonal 2. For that, what is that, a kite and a rhombus? Okay. You could also have 1/2 base 1, base 2 plus base 2 times height. Am I forgetting any? You could also have a circle. What would the circle be? R squared. And those are the only two-dimensional formulas I believe that we've done so far, but any one of those bases, any one of those figures could be the bases. That is kite and rhombus, which is cool.
Base 1 plus base 2?
Correct, and that is because it is average your bases multiplied by the height. Does anybody have any questions on that? Okay, in that case, I am going to scroll up. You need to put those down. So could I have gone over and given you 1, 2, 3, 4, 5, 6 different formulas? You could have had 1/2 base height height. You could have had 1/2 base height. There's just, you could have so many different ones. Base height times the height of the figure. You could have all these formulas, but rather we just understand it and we adjust the formula as needed. The first one, is this figure the base on top of itself a bunch of times? Yes. So this one is going to be volume equals area of base times big H, which is height of the 3D figure. The key to doing okay in this chapter is just showing all your work. If you don't show your work, you're going to die in this chapter. If you show it, it's pretty easy. It's just formulas. Yeah, you shouldn't actually die. Okay. So now I know that the area of the base, since it is a rectangle, is 24 times 20. That is the area of the base, and the height of the figure is 10. I'm all about being lazy and efficient. Once you show me what you're putting in your calculator, then just put it in your calculator. So put 24 times 20 times 10 in your calculator and press enter.
We miss you guys.
Yeah, I feel like it is. No.
What? Me?
4,800 centimeters cubed squared. What's it going to be? Cubed, because it's that how many little 1 by 1 by 1 sugar cubes can go inside. So on your homework, it asks for just the number. You will put 4,800 Don't even put a comma in there. Just put 4800. Does anybody have any questions? Let's move on to the next one. Let's assume that the bottom is the base. Let's assume this rectangle is the base. If I stack that rectangle on top of itself over and over and over, would I get this figure? You would not. What about if I thought of the base as the triangle? If I stack that triangle on top of itself over and over and over, would I get the figure? Yes. Question. Yeah. So on this one, we know it is going to be volume equals area of base times height, the generic formula. We know that the base is a triangle, so I will put 1/2 6 times 10. Now here is the confusing part. People always think of height as up and down, and they think of the base as the bottom. In this case, the base is in the front. So which number gives us our height? 5. Big H is 5. I believe that's 150. Okay. And that gives us 150 meters cubed. Make sure you know bottom is not always base, up and down is not always height. Make sure you know there's a difference between little h and big H. A difference between little b and big B. Big B is area of the base. Big H is height of the whole figure. Little b is the base of the base. Little h is height of the base. Unit? No, I don't care about that. And you'll see that sometimes I accidentally put a baby h. It doesn't.
Well, you take that point, you don't write the formula.
Yes.
Oh.
Yep. I know.
I'm just hoping one day he'll say
No.
no.
Okay, so it's like you ask me, hey, will you give me a ticket if I don't put my blinker on when I change lanes? And I'm like, as a person who's giving you advice, trying to keep you out of accidents, my answer is always put on your blinker. Will you get a ticket every time? Absolutely not. Will you get away with not doing it? 100%. Half of the time you're going to forget to use your blinker, but it's not a good habit to get it. Okay, this one right here, is this the base stacked on top of itself over and over and over?
Yeah.
Then let's put volume equals area of base times height. Which variation is it? It's a regular polygon, so the base is 1/2 apothem times perimeter. Should probably zoom in so that they can see this. Zoom, zoom, zoom. Okay. All right. So the base is 1/2 apothem times perimeter. If you want to go all the way to here, that's even better. I could see you going over and going from here straight to putting your numbers in. So we can put in 1/2. If this whole thing is 8, half of it's 4, and what is your apothem going to be? 4 add 3. And the perimeter is 48. And the height of the figure is 10. And we're always going to want to have an exact answer. So we're going to figure out what the numbers multiply to and then leave it as rad 3. Half of 4 is 2. 2 times 10 is 20. 20 times 48 is 960, right? So for everything other than your homework, you will put 960 rad 3 inches cubed. For your homework, you will put 960 rad 3. Just what? Lowercase say rad. Yeah, you can't put it in Google Sheets. Okay, so here's the deal. If I do Math Excel, it was just terrible. I didn't want to do that. If I went over and I give you a worksheet, I'm a little lazy and efficient. I'm probably not going to grade every single problem, and you could have done every single one wrong and still gotten full credit. If I do this method, then I get to see your work because you're going to turn in a picture, and you're graded based off of actually knowing the material. But there's a huge buffer because you can get a D on the homework and get 100%, which is nice. All right, returning from the bathroom, you're going to want to finish these, get these notes down. The main things that you missed. A, the first problem is easy. B, this one is easy except for people are always going to think the bottom is the base and this is the height. Make sure you know the base is actually the triangle and the height is the 5. And number 3, the only challenge is if you don't know your 30, 60, 90s. Okay, now as we move on here, on this problem, it is, because this thing is still the base on top of itself. If you looked in the back of our book, if you had the physical book, it would say For a cylinder, memorize the formula pi r squared h. And we know that is them trying to collect money for the same exact formula. Pi r squared is just area of base, and h is your height. We don't have enough of them. We only had enough for study halls, and then you guys used online, and then when they switched to Pearson trying to force us to buy the new book, they didn't have online books anymore, so we just got rid of books. Yep. All right, here we go. Let's go. So, on topic. Okay, so as you can see here, this is just a bunch of flat circles stacked on top of one another. So we know that it will be volume equals area of base times height. You guys will have a chance to practice these on your own. This is just us practicing together. So this one would be pi r squared h, which is pi r squared h. And that gives you 150 pi meters cubed. And on your homework, you will say 150 pi, lowercase, no units. For the homework, it's just instead of a pi, you're going to put pi. If only you just missed the conversation we just had. There you go. All right, let's switch this problem up a little bit. Let's get rid of that, and let's put this as 45, and let's make that as 10. Yep, I'm a jerk. You'll be fine. Okay, volume equals area of the base times the height. Shh. Make sure I can do my job. Pi r squared h. What do we have? We got the r. What do we not have? We need the h. So I can already put in pi, 5 up there or 6? 5 squared. We just don't know the height. Here is your height there. So if this is a 45, 45, 90, and that's 10, how do we go from here to here?
Making us divide.
Yes, divide by what? But which one? That would be if it was getting bigger. It's getting smaller. So we need to divide by rad 2, right? 10 rad 2 over 2, which is 5 rad 2. Oh, did you? Oh, I'm sorry. I thought you said 10 rad 2. Yeah, you're good. So that would be pi times 25 times 5 rad 2. 25 times 5 is 125. Rad 2 pi, or 125 pi rad 2.
Does it matter the order?
I mean, this one it looks ugly no matter what. Usually you put numbers before you get to your pi. Yeah, it just sounds funny. Does anybody have any questions on this? Okay, here's your time to, sorry, Cavallari's principle. I forgot about that. All right, so what Cavallari principle says, if two figures have the same exact height and have all of the cross-sectional areas that are the same at every level. So let's say we had this, and we know that all of the cross-sections here are going to look the same. Let's say that the circle area was congruent to the rectangle area, which was congruent to the triangle area. Then what do we know about all of the figures? They all have the same what? If all of the cross-sections have the same area and they have the same exact height, they will all have the same volume. And that should make sense because it's basically saying if it's the same area stacked on top of itself over and over and over, they're going to have the same volume. You might say, well, how could this be? Well, let's say this was 4, then that area would be pi r squared, 16 pi. Then this was 8 pi by 2. Why would it have a length of 8 pi? Well, I don't know. Just trying to make it work. That would also be 16 pi. And if this was 16 pi with a height of 2 and you did the area, it would also come out to be 16 pi. Since all of the areas are equal and the heights are the same, then all of the volumes will be equal. Does anybody have any questions about what Cavallari's principle says? Sounds like a type of pasta. Which type of pasta do you want? Oh, I'd like to have Cavallari's. Okay, here we go. Now what you guys are going to do is you are going to do these problems. If you are at home, it is in your best interest to try these problems on your own. I'm trying to zoom in so you can see the numbers. Pause the video, try the problems, and see if you get them right. Figure out, remember, the bottom is not always the base. The up and down is not always the height. Figure out what the base is, what the height is. It doesn't matter. So that's the cool thing. It's not like lateral area where you're going to get different things. You can call the 3 times 4 the base, the 5 times 3 the base on A. It does not matter. Pause the video, people at home. When you are done with these problems, unpause. On the first one, you know this is just the base stacked on top of itself over and over and over. So this is area of base times height. The base is a rectangle, which is 5 times 3 times height, which is 4. You could have also picked the 3 times 4 to be the base, and because it could have been that as the rectangle stacked on top. You should get 60 feet cubed. The next one, it is insanely important for you to know the base is not the bottom. The base is the triangle. It's also important for you to know that the height is not 16, the height is 10. The definition of height is the distance between the bases. If you do not know your 30, 60, 90s, you will not be able to do a two-dimensional regular polygon. If you can't do a two-dimensional regular polygon, you can't do surface area, you can't do volume. So make sure you know first this, then the two-dimensional, then the three-dimensional. As you can see, I did area of base, which is 1/2 Botham times perimeter times height, and that was that. The next one, I could see it's just a circle stacked on top of itself over and over and over and over and over. So I knew I had my radius, I just needed the height. I used 30, 60, 90s to find the height, and I went from there. Does anybody have any questions on any of these? Normally, if we had a full long period, your next problem, let me go ahead and boom, 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 boom. Your next problem would have been something called a composite figure. So your next problem would have looked like this. We will do one of these later. So this would have been your problem, and all you would have needed to do is you would have had to say, we have no formula for this figure. What I do know it is going to be a rectangular prism plus 1/2 of a cylinder. You always come up with a plan that you know is 100% correct, and then you build off it. Then you know it is area base times height plus 1/2 pi r squared h. Now you had something that you knew was 100% true. Then you filled it in with formulas that you know are 100% correct, and then you would go over and gather up your information and put your numbers into here. Does anybody have any questions on that? So here is one of the last problems we are going to get to. What the deal is with this problem is I've already told you that I was never great in math. I had to come up with little skills to help me work with or to be able to do problems successfully with my limited math skills. One of my things that I teach my algebra kids is if the numbers are hard, if the problem is hard because of the numbers, like you have fractions and decimals, just go, what would I have done if these weren't fractions and decimals? How would I have done this problem? The other little skill that I came up with is when all else fails, draw a picture. The other thing is, if you already have a picture, when all else fails, write down the what. The what? The knowns, and figure out what you don't know. But if you have a figure like this, what do we know we always use for a figure like this? We use a formula. So what you do is you say, well, let's just fill in the formula. When all else fails, write down the formula, put stuff in, and hope there is only one thing missing. If there's only one thing missing, you will be able to solve the problem. So on here, we know volume equals area of base times height, aka pi r squared times height. And let's hope that when we put everything in, there is one piece missing. They tell us the volume. It is 1253 equals pi. They don't know the radius, so it's x squared, and we know the height. Don't put it in your calculator yet. You're going to do it wrong. Or go ahead, try, and let's see if you get it wrong. We'll see. Okay, so at this point, we know at some point we're going to have to undo squaring. How do we undo squaring? Square rooting. But the deal is you need to get the x squared by itself. So here is mistake number one that people do. They will first divide by 10, and then they will divide by pi, and they get super scared because you have a triple-decker fraction. If you divide by 10, enter, and then leave that number in your calculator, and then divide using the pi button, you will be fine, but you'll have some weird decimal. Another thing you guys can do is you can divide by 10 and by pi at the same time. Now, if you do that, you need to make sure you have parentheses, because you are going to say divided by 10 pi, and if you put it in like that, The calculator is like the smartest and the stupidest thing at the same time. It is amazing because it can do all of the different calculations. It is dumb because it does not know right now that you mean divide by 10 pi unless you put parentheses here. Otherwise, it will divide by pi and then it'll be like, oh, it wanted the people want me to divide by pi or divide by 10 and then multiply by pi. So make sure you have parentheses here. When you put that in your calculator, what do you get? And there should be a pi button in your calculator. If you don't have a pi button, you probably will be able to get by with 3.1415. But when you do 1253 divided by 10 pi, you end up with?
39.88.
Okay, if you are going to round, since we're going to square root this, go very, very far. Give me like 4 or 5 numbers. 39 point. Okay, that should be good. And then you should be able to square root that and you will get your answer. Another thing you could have done is when it was in your calculator, you could have pushed the store button and then you could have pressed the X button. And then that exact number would have been in your calculator and you would have been able to say square root of X and it would have square rooted the exact number, which would have been really cool. What do you end up getting when you square root 39.8842? 3.1, I'm going to say approximately 6.3. I believe the problem I give you in your homework is much easier because it is a rectangular prism where you're not going to have like r squared in it, where you have to solve by square rooting. Hey, how many formulas did you guys learn today? One, only one. And that formula is if it is the same thing stacked on top of itself, volume equals area of base times height. That formula might go over and change to be some different things, but really it's just one formula. Anybody have any questions? Great. Don't forget to read the directions on how I want the answers on your homework. Thank you very much for watching.